This is my video proof that the composition of two continuous functions is also a continuous function. Alright, so we're going to go ahead and make sure we define everything really properly. So the technical proof that we're doing is if f goes from d to the real numbers and g goes from d prime to the real numbers with the image of f contained in d prime, where f is continuous at x naught in d and g is continuous at f of x naught, then g of f is continuous at x naught. So, to prove this, we're going to go ahead and choose epsilon greater than 0. Then we know that there's going to exist a delta sub 1 greater than 0, so that if the absolute value of y minus f of x naught is less than delta, and y is an element of d prime, then g of y minus g of f of x, g of f of x naught is going to be less than epsilon. Alright, well, let's go ahead and choose a delta 2, so that if the absolute value of x minus x naught is less than delta 2, and x is an element of d, then f of x minus f of x naught is less than delta 1. Now, we're using delta 1 here as a specific epsilon because we know it'll work for any epsilon. So we want it to work for, so we're going to use delta 1 as our epsilon in that particular case. Well, now since the image of f is contained in d prime, if the absolute value of x minus x naught is less than delta 2 and x is an element of d, well then f of x is in d prime and f of x naught is in d prime, and well, the absolute value of f of x minus f of x naught is less than delta 1. Hence, we're going to have the absolute value of g of x minus g of f of x naught less than epsilon, just by replacing the y from our by replacing g of y with g of f of x. So basically allowing y to be equal to f of x. So therefore g of x is continuous, or g of f is continuous at x